Okay, ladies and gentlemen, tonight we are going to write our own equations. So they're just one-step story problems. So a lot of these, I bet you know what to do to find the answer. But what we're working on today is how to actually write the equation. All right. So I'm going to read through these story problems and kind of think through what I'm doing to set up my equation. Okay, number one, we need to define our variable. Okay, what does x equal? Then we're going to set up the equation and then we're going to answer it. When you are answering a story problem, you always want to include a unit. Are you talking about dollars? Are you talking about pages? Are you talking about dogs? Okay, so make sure you always include a unit when you write your solutions on this page. All right, number one is done for us, and I did all of the steps included. So let's read number two. 3 sodas cost $4.95. What is the cost of 1 soda? All right, so first, number one, it said to identify your variable. So x is representing our cost, so money, of 1 soda. Okay, so I'm thinking through this, and I know there isn't a number there, but I know the word 3 is 3. Sometimes when it's written in words, people don't notice it. And then cost, that's my equals, the $4.95. So let's write that into an equation. So if I take 3 times however much 1 soda cost, it'll give me my total of $4.95. Okay, so I'm buying 3 sodas for the cost of X dollars, and my total payment is the $4.95. All right, so let's put that in the equation box. 3x equals 4.95. Okay, if we have time, I'll come back and write that solution with you. Now looking at number 3. Maggie spent half of her money in her savings account on a new computer. If the computer was $345, how much money was in her savings account? All right, so X is representing how much money was in her account. Okay, I'm just going to write money. Now, to put it into an equation, she spent half of her account, which is our variable. So there's 2 ways I can write that. I can write 1/2 times how much money I have in my account, and then that equals the $345. Okay, or I could, so you could put that in the box, or I could say I take my money and I divide it by 2, because that means the same thing as a half. So either one of these equations would be awesome. Okay, again, if we have time, we'll go back and solve that. All right, for number 4, I went ahead and drew a diagram off to the side, because with the elevation questions, a lot of times I get confused on did I start negative or end negative and all that jazz. So I kind of drew a visual. A shark descended the 32 6/10. So that's that blue line going down, because descended is going down. That's a subtraction. To catch a fish. The shark is now, that's the finish, at that negative 82 25/100. So what was his starting position? So we got to figure out what x is. So x is your start. All right, now let's put that into an organized equation. Okay, we start at an unknown elevation, and then we descend, we subtract 32 6/10, and then we end up at our, now at is our equals, that's our final destination, negative 82 25/100. Okay, so equation is a subtraction problem, and our inverse operation is going to be subtraction. Okay, so you got to watch out for your negative rules on this one, because you got decimals and negatives to stress over. So hopefully we have time to go back and solve that one. All right, number 5, we have 14 students in an art class. Mr. Travis has 350 pencils to distribute. So 14 kiddos and 350 pencils. Now distributing equally Oh man, that makes me think division, but we got to be careful. How many color pencils will each student receive? Now, if we take the 350 and divide it by 14, that'll give us our answer, right? That'll give us X. X is representing the number of colored pencils each people will get, student. Number of pencils. But this isn't really an equation, okay? It's what we're going to do, but that's going to be our inverse operation. So we got to rethink this as a 7th grader. How can I set that up to an equation? Well, here's what I'm thinking. If I have 14 kiddos, they all get some pencils, so I can multiply it by the number of pencils they get, I should end up with the 350. So I'm kind of thinking it through backwards. I know I'm going to divide by 14 to get my answer, but that's not really an equation. All right, so here's what I'm going to be looking for as far as an equation. The number of students times however many pencils they get will give you the 350. Okay, so do you see the difference between an equation and this not being an equation, really? That's just how you solve it. All right, so good thing we're stretching our brains today. All right, number 6. Caitlin made 6 dozen more cupcakes than Melissa. If Caitlin made 88, how many did Melissa make? All right, I'm going to make this variable m, because that just seems like a good thing to do. M represents the number of cupcakes that Melissa made. Okay, I don't know where the E went. All right, so these always confuse me because I got to think, well, who made more and who made less? So if Caitlin made more, that means Melissa made less, right? Okay, so I'm going to kind of parenthesize this. 6 dozen more cupcakes than Melissa. Remember, than is one of those turnaround words. All right, so that means Melissa plus 6 will give you however many Caitlin made. Okay, but I can't have two variables, right? So what other information did they give us? Well, they told us that Caitlin made 88. So I'm going to rewrite this with Melissa plus 6 dozen gives me 88. Okay, and just to double check myself, Caitlin made more. So that's true. Okay, so if I take Melissa plus the 6 dozen, I'm good to go. So Melissa plus 6 equals 88 cupcakes, or dozen cupcakes. All right, number 7, mixed numbers, oh my. Let's see, Paul bought 3 1/3 pounds of bananas and apples, so that's the combined. If he bought 1 4/5 pounds of just apples, okay, that's just apples, how many pounds of bananas did he buy? Okay, so B is going to represent bananas. B-A-N-A-N-A-S. Okay. All right, so if I take apple plus banana, I get total, right? We can write that. That's an equation. Now let's fill in the information that I know. Apples, I circled that. That was the 1 4/5 plus bananas is our unknown. We're going to leave the variable B, and then this 3 1/3 was apples and bananas together. So equals 3 1/3. All right, that'll be a fun one to solve. Transfer that over to your equation box, and we got one more to go. All right, one more, number 8. Snow is falling at a rate of 2.5 inches per hour. Unit rate, yay. Okay, at this rate, how long, okay, so that's our variable. How long will it take it to snow 8 inches? Okay, so how long is our unknown, and we know it's in terms of hours. So here's my thought process on this. So if it's snowing 2.5 inches every single hour, if it snows for 3 hours, I would times it by 3. If it snows for 4 hours, I would times it by 4. So kind of writing it out in a sentence again, I take 2.5 inches times however many hours it's snowing. So 2.5 times x equals the 8 hours that or the 8 inches, sorry, that we're wanting to get. All right, there we go. Thank you for watching.